Swayam Prabha. Digital India. Educated India.
Dear friends, welcome to this second lecture of Module 12 on engineering geological aspects of geothermal energy, coal bed methane, gas hydrate, shale gas, carbon capture, usage and storage. In previous discussion, we have discussed about introductory aspects related to energy, both renewable and non-renewable energy. Then effect of emission of gases like carbon dioxide to atmosphere and their impacts. In these lectures, we will discuss about enhanced geothermal system and engineering geological issues concerned to extraction of geothermal energy and requirements. Today we are going to elaborate about geothermal resources and enhance geothermal system along with engineering geological issues and requirement. Regarding this, we will discuss about geothermal system, then conventional geothermal system, hydrothermal system, and then unconventional geothermal system, then steps in enhanced geothermal system and supercritical enhanced geothermal system, then engineering geological issues and required approaches. Friends, as you know, the geothermal resource is one of renewable energy resources, fall in domain of green energy. It is one of options to reduce the hazardous emission to atmosphere and reduce the problem of continuous increasing temperature at global level in form of climate change. As per US Department of Energy, unconventional geothermal resources, which is technologies application to increase geothermal energy production to exploit economically feasible amount of heat are called as enhanced geothermal system. The technological application utilized in this system by enhancing permeability of rock strata in order to increase the extent of productive geothermal field. Next aspect related to improving drilling and reservoir assessment parameters and expertises, then improving the thermodynamic cycles and introducing supercritical fluid system for proper extraction of geothermal energy and improving exploration method. As far as geothermal energy is concerned, this energy is confined to conventional geothermal system and unconventional geothermal system. In conventional geothermal system, you can see here in this figure along with this descriptions, these systems are characterized by reservoir having high permeable rock strata with inherent discontinuity. The reservoir is characterized by presence of discontinuity assisted enhanced permeability. high permeability, which can allow the movement of the geothermal energy or the carriers of the geothermal energy to the surface through different artificial arrangement. In such reservoir, the discontinuities are work as conduct for the circulation of fluid present in reservoir. And third, the such circulated fluids are extracted in form of geothermal heat through bellbore drawn inside the reservoir. As far as the structural features of geothermal reservoir is concerned, the reservoir is characterized by high permeability due to presence of discontinuities like joints, like fractures, like cracks, and allowability of the fluids make the reservoir suitable for extraction of geothermal energy. Where the discontinuities is acting as a conduct for movement of heated fluid which can be extracted on the surface in form of hot water or in form of steam and utilized for industrial purpose like generation of electricity or for other energy. The principal use of such steam to generate electricity. Such type of locations, such type of geological setup consist of some overlying strata, then some reservoir strata above the heat source. The fluid may be hot air, the fluid may be water. Generally, we utilize or look about the hydrothermal fluid. As far as this setting of geothermal field is concerned, we can see the strata lying below the surface, saturated with water at different level and marked by, in unconfined situations, marked by underground water table that going to feed. The movement of the groundwater through the strata move toward the heat source, and when such inflow of the water interact with the heat source, due to change in temperature condition, there is some formation of some or the development of some convection current type of situation. This heated inflow water after interaction move toward the outflow direction, and this distribution of the heated water recovered from the extracted hole. Sometimes naturally it comes in form of geyser. You can see the heat of the earth in these kinds of conventional geothermal resources are extracted by convective circulation of fluids is called as hydrothermal system. Where the availability of fluids present, then the movement of the fluid from the upper surfacial area or subsurfacial area toward the heat source make some difference in temperature due to heat exchange from the source, and in this situation the fluid starts making some convection current due to temperature difference, and such convection currents are suitable to make the whole system full of hot water that can be released through such type of artificial bellbore. This type of geothermal systems are usually observed are located near the tectonic boundaries and volcanoes. In our discussions, we have discussed three types of boundary: tectonic boundary, in which the diverging setup of plates is suitable for the ingress or intrusion of the hot magma close to the surface and become principal source of heat for such type of conversion of water, inflow of water in heated state and released in form of outflow. In these locations, the crust is traversed by number of and varieties of discontinuities, that responsible for improved permeability of the system. In these locations, the crust is traversed by discontinuities and providing heat source. The hydrothermal system imparts high geothermal gradient and sufficient volume of hot water. This high gradient, particularly geothermal gradient, and available sufficient volume of hot water facilitate the availability of hot water streams economically for industrial use. Besides this type of conventional geothermal system, we have unconventional geothermal system also available throughout the suitable location throughout the world. And the unconventional geothermal systems are non-hydrothermal resources. In this system, the water is not available for movement or for changing their position from one point to another point to reach the heat source. In this system, reservoir having low permeability and inadequate amount of stored fluid. Therefore, we are recognizing this type of system as non-hydrothermal system. These kinds of geothermal energy resources are huge, but having reservoir of low permeability and limited quantity of fluid. Therefore, very difficult to extract geothermal energy. Therefore, still conventional geothermal systems are used in extraction of geothermal energy. However, the unconventional geothermal system has huge quantity of geothermal energy sufficient to solve the problem of energy demand and in form of clean and green energy. Therefore, we have to think about such resources. In case of enhanced geothermal systems, we have different steps to extract geothermal energy. First, here, this is the general view. The surfacial part, subsurfacial, shallow depth, then slightly higher depth, then the rock strata having some inherent discontinuities. You can see here inherent discontinuities, etc. So, reservoir having inherent discontinuity responsible for considerable permeability in tune of high. For extraction of geothermal energy in initial steps, first we are going to create well into a rock body through drilling. So first step is a creation of well. Second step is a pumping up high pressure water, into drilled well. Initially we are going to select the location, then after selection of suitable location, then we are going to drill the hole to inject the water in reservoir having source or become location for extraction of geothermal energy. Due to injection of water inside the drilled hole, the inherent discontinuities present in reservoir has started opening or opened with increased aperture, increased opening, as well as formation of additional fracture due to injection of water induced pressure. Therefore, you can see after injection of water, there is a development of a network of discontinuities. The enhanced discontinuity is responsible to provide conduits for the movement of the fluid as well as enhance the permeability of reservoir suitable for extraction of geothermal energy. So pumping up water going to enhance the discontinuities, reopen the inherent discontinuities and improve the permeability. In such situation, the continuous injection of water when come in contact with the heat source, then this heated water recovered from the another bell hole or drill hole and utilized in system. So heating up high pressure water, injected water by the inherent high heated hard dry rock strata of the reservoir. The heated water then extracted. So extraction of the heated fluid through production well. This is injection well and this is production well. As this well is utilized for injection of water, when this injected water going to work in two ways. First, going to increase the permeability of reservoir. Second, this injected water going to interact with the rocks at higher temperature and the injected water become hot fluid. The hot fluid move from this location to another location as the nature due to temperature difference, and the production well is suitable to extract the heated water. So turning up heated water into steam to drive steam turbines for power generations are utilized after collection of the heat water or the steams in such situation for generation of electricity. You can see the generation of here, the injection of the water through injection well, there is increase in or enhancement in permeability, and the injected water when come in contact with the hot source, then started moving from lower temperature to some other temperature level, and that can be recovered through the production well in form of steam, and that steams can be utilized for the movement of turbines for generation of electricity and supply to the industry. When in view of the mechanics, when we are going to inject the water is going to first reopen the inherent discontinuities like fracture cracks present in reservoir. Beside the increase in aperture of the discontinuities, the injected water induced pressure is responsible for formation of some new discontinuities also, new fractures also. In this way, the injected water is going to result the widening of the discontinuity as will increase in frequency of discontinuities. Beside this, the injected water present in reservoir and the reservoir is at higher temperature, then the injected water after interaction with this hot system become hot in nature and come in form of sometimes vapor, sometimes water, and recovered this heated water and heated steams recovered through the production well and utilized for generation of electricity. The fracture is of two types, intragranular as well as intergranular. The injected water are sufficient to develop cracks in matrix also, within the grains also. In this way, their injection of the water is going to help in enhancing the permeability of reservoir that required for extraction of hot water or geothermal energy. Beside this conventional hydrothermal system, then unconventional system utilizing some waters and others to improve the permeability become a future site for extraction of geothermal energy. Beside these, alternative options are also available for improving the permeability of the system. You can see, in place of water injection or water vapor injection, the system utilizes the injection of supercritical carbon dioxide. Supercritical carbon dioxide in place of water. So this is one alternative approach. In this, besides supercritical water vapor based geothermal system, an alternative unconventional geothermal system based on the supercritical carbon dioxide can be used both for improving the permeability as well as for making suitable zone for extraction of geothermal energy. So supercritical carbon dioxide is utilized both for fracturing and circulation of fluid concerned to extraction of geothermal energy. In this system, we are going to create a zone with help of the horizontal drilling system in number of strips and use of some systems to make this zone fragmented in nature. So the system consists of a number of vertically interconnected strips which are formed through horizontal drilling and fracture induced for formation of such reservoir. In this way, we are going to create a tunnel type of situation, a tunnel type of structures full of rock fragments with enhanced permeability that provide space for the movement of fluid, and the injection of supercritical carbon dioxide through the horizontal approach is going to facilitate the extraction of geothermal energy. The system is comprised of a huge volume of heating source with high permeability due to fragmentation of the rock strata in form of readily stretched tunnels and shaft system. Through horizontal drilling, we are going to create a tunnel type of structures that the different at another end it is connected with the shaft system, and this system is suitable for the instruction of huge amount of geothermal energy from the reservoir, which is an unconventional reservoir not utilized through previously conventional approaches. The system has two benefits. On one side, we are going to utilize the supercritical carbon dioxide, and carbon dioxide, problematic for the development of greenhouse gases or formation of greenhouse gases induced climatic impacts. The system has the potential to extend the scale of heat exchange to achieve large scale geothermal extraction and provide good amount of heat energy through this geothermal system. Here in this system, we are going to create one zone through different level of horizontal drilling and other method of fragmentation, and the energy recovered through the vertical shaft. The geothermal energy is a green energy, renewable energy, can be extracted through conventional and unconventional systems. However, the system is suitable to suppress the greenhouse gases and reduce the increment in global temperature. However, the extraction induced problems related to geothermal extraction can be addressed in view of engineering geological issues and required approaches. From the engineering geological point of view, it is necessary to know the rheological mechanical features of the reservoir strata in pre, sin and post development of reservoir under extreme geothermal condition. So, first issue related to engineering geology is question about the rheological mechanical behavior of the strata at elevated high temperature condition. Second, the problem is associated with the short and long term behavior of the reservoir. Therefore, both short and long term reservoir performance need to be evaluated properly, sincerely and timely with the associated coupled thermo, hydromechanical and chemical influences. For this, reservoir characterization is necessary to understand geothermal gradient, the magnitude and orientation of stress in reservoir, about tectonics and seismicity, and geomechanical and hydraulic characteristics of reservoir rock strata, such as inherent cracks, inherent discontinuity like joints, faults, fractures, and any type of discontinuity, etc. Then about the inherent constituents as well as their arrangement, concern to mineralogy and texture of the rock strata. These parameters of reservoir is changing from time to time as well as from position to position, which are a major task in form of engineering geological issues. These works are required to minimize or solve this such type of enhanced temperature induced problems. Without the proper solution of the questions related to the geothermal gradient uncertainty, about the improper assessment of the stress present in reservoir, as well as tectonic and seismic condition of the area or the strata, then hydraulic and mechanical response of the strata due to presence of inherent discontinuity, as well as expected reopening and formation of new discontinuities. Then about the petrological response of rocks present in reservoir. It is important to assess the induced seismicity associated with the injection of water, carbon dioxide and extraction of fluid. Friends, as you know, when we are going to insert any fluid inside and going to create discontinuities, as we are practicing in case of geothermal energy, when we are going to inject the water or inject the carbon dioxide, then there is a formation of discontinuities in form of fractures and cracks, and the formation of fractures and crack becomes site for burst of energy, burst of mechanical energy, and the burst of mechanical energy after summation is going to create seismic waves, because the mechanical energy come in form of mechanical waves, and the mechanical waves are nothing, it is a P wave, S wave and P and S wave induced Ln R wave, mainly P wave and S wave. So the problem of induced seismicity associated with injection of water and recovery of water is going to change the straight state of the reservoir or the geothermal system. In such situation, this strata is subjected to increment in pressure due to injection of water and decrement in pressure due to extraction of heat water. So this system experience cyclic type of stressing. And friends, under the cyclic loading type of situation, any rock strata or even any rock is going to show reduced strength. In such situation, there is a chances of further development of the discontinuities, and such discontinuity is responsible for induced seismicity. The higher magnitude of induced seismicity may be going to create some problem and to society and others. So we should take care about the seismicity. Next important is permeability evaluation, because all the business related to extraction of geothermal energy is a concern to the permeability and availability of the discontinuity. So the permeability of fractures or discontinuity of reservoir depends on the fracture aperture, means mouth, as well as tortuosity, because these fractures or discontinuities are acting as a conduit. Therefore, the creation of fracture discontinuity needs minimum tortuosity and maximum fracture aperture to facilitate the movement of the heated fluid. For this, a large planar hydraulic fracture is initially created perpendicular to the minimum horizontal stress direction. Second, in phase of the opening of fractures or discontinuity created by tensile failure, has a number of micro cracks as a result of shear failure in the surrounding rock matrix as well as in grain also, resulting in a well-developed fracture network that is going to help in extraction of geothermal energy. This process, which is known as hydrosearing, is based on the induced slip on pre-existing or inherent discontinuity while no fracture opening occurs. Again, the separation along already present fracture planes is usually expected, which are resulting dilation in the reservoir, and the dilation of reservoir is an indicator of the enhanced permeability that going to facilitate the movement of the fluid as well as increment in permeability and proper release of the heated fluid. This process of hydraulic fracturing can be split in several steps as some common practice. Besides this, it is important to understand the coupled thermomechanical characteristic of rocks and the failure and formation of various types of fractures, cracks and discontinuities due to injection of water and recovery of water, heated water for geothermal energy extraction. The behavior of rock in normal condition is different when subjected to both temperature and the stress. Then the behavior is different. Very limited works are available on the thermomechanical characteristic. The similar type of situations, as we have already discussed, can be performed under a specialized system under thermomechanical behavior. Friends, this topic I have prepared from number of references taken from research papers. As far as conclusion of this aspect is concerned, the geothermal system is classified as conventional and unconventional geothermal systems. The geothermal systems are commonly located close to the plate boundary or the site of volcanic activities. The pertinently distributed both inherent and induced discontinuities as fractures as well as availability of fluids are the principal parameter for characterization of the geothermal reservoir. And the geothermal reservoir characterizations requires the input of the geothermal gradient, stress, both magnitude and direction of stress present in reservoir, then about the tectonics and seismicity status of the reservoir or area where the reservoir is located, and then about the geomechanical, thermomechanical and hydraulic characteristic of reservoir such as inherent discontinuities like fault joints and fracture etc., and the textural and petrological characteristics of rock strata or rocks are required for proper assessment of the geothermal reservoir. Both short and long term reservoir performance required to be assessed through coupled thermo, hydro-mechanical and chemical attribute to avoid the engineering geological issues as well as the fear of induced seismicity in peoples of the society. Dear friends, in this class we have elaborated about different technical aspects of geothermal energy, the way for the instruction of geothermal energy, both conventional and unconventional, and then engineering geological issues and their some mitigation. Thank you very much for your patience hearing. Thank you.